All right, so the solution of many optimization problems actually involves searching for an absolute extremum. Now, if the function in question has only one critical number, then the second derivative test for local extrema not only classifies the local extremum, but also guarantees that the local extremum is, in fact, the absolute extremum. All right, so this gives us theorem 3, which says the second derivative test for absolute extrema are on an interval. So let f be continuous on the interval I, so wherever the interval is, from A to B, with only one critical number C in that interval. So it's going to be here or here, basically. Now, the first derivative of at C is equal to 0, and the second derivative is going to be greater than 0, then f of C is the absolute minimum of f on I. And if first derivative at C is equal to 0 and the second derivative at C is less than 0, then f of C is the absolute maximum of f on I. And so that's why if we have only one critical number, that gives us exactly what we need there as far as the values. So let's say we have the following two problems. We want to find the absolute extrema of each function on the interval. Now notice we have the interval from 0 to infinity. So if we get a negative value or something for a critical number, then we know we can just kind of get rid of it. So let's do A. So what do we need to do first? Well, our first things is find the first derivative. Well, that goes away. We get a -1. And then this is actually x to the -1. And so a -1 times a -1 is going to be plus, and it's going to be a 5. And that becomes a -2. So then we have over x squared. Okay. Now, if we set this equal to 0, we get 5 over x squared is equal to 1. And then that gives us x squared equals 5. So x equals plus or minus the square root of 5. Okay. But guess what? Again, we're on that interval here. So really, we just have the critical number is square root of 5 because we have to get rid of that -1. So we just have the one critical number. All right, so then, all right, so what is then our second derivative? Okay, well, that's going to be, now this takes this up, and that's going to disappear. So we're going to have -2 times 5. So it's going to be a -10 that becomes x to the third. Okay. So now we're going to test this critical number with this. So f double prime of the square root of 5. Now, if we plug that in, that's going to give us a negative value. So it really doesn't matter what the negative is. If we plug it in, we get a negative 0.89, which is less than 0. So that means it's going to be a local max. Okay. And so what is that going to be a local max of? Well, now we have to actually plug it in and find the f of square root of 5. So if we plug that in, that's going to be 12 minus the square root of 5 minus 5 over square root of 5. Now, we don't like square roots in the denominator, so let's multiply by the square root of 5 over square root of 5. So that gives us 12 minus the square root of 5 minus, and now we have 5 square root of 5 over 5. Well, okay, so this basically goes to 5 square root of 5 over 5. Well, 5 over 5, those cancel, so let's write that as they cancel. And so this then just becomes square root of 5. Well, then what we can do is simplify that. And where's my minus there? It disappeared, or it became part of the square root anyway. So now we have 12 minus 2 square root of 5. And so that's going to be my local max. So at square root of 5, comma, 12 minus 2 square root of 5, that's going to be the local max. Okay. So that's how we would use it because we only had that one critical number. Well, how would we do this one? Well, we're going to do something similar. We're going to first find the first derivative. Derivative of ln of x is 1 over x. So that's going to be 5 over x. Derivative that's going to be -1. Again, we're going to set that equal to 0. So 5 over x equals 1. X equals 5. Okay, well, 5 is in that interval, so we're good to go there. So now what we need to do is find the second derivative at that. Well, that's x to the -1, so that's a -5 over x squared. So -5 over x squared. All right, so f double prime of now our critical number is 5. So it's a minus 5 over a 5 squared. So that's going to be a negative 1/5. That's less than 0. So what do we have here again? Well, we have a local max. So that was kind of nice. Now, what is the local max? Well, that's going to be f of 5, which is going to be 5 times ln of 5 minus 5. And so, at 5 comma 5 ln of 5 minus 5, that's going to be our local max. And again, that's because we just had the one critical number, so we know that that's going to be what it is, and we're good to go there. With the second derivative test taken into consideration, of course. All right, so I think that should get you on how to do most of the problems for this section. So hopefully that will help.